Peak of a flood hydrograph due to 6-hour storm is 470 cubic meters per second. The average depth of rainfall is given as 8 centimeters. Assume an infiltration loss of 0.25 centimeters per hour and consists of base flow of 15 cubic meters per second. Calculate the peak discharge if 6-hour hydrograph for this catchment. So discharge, peak discharge is 470 cubic meters per second, base flow 15 cubic meters per second, peak discharge of surface runoff hydrograph is discharge of flood hydrograph minus base flow, that is 455 cubic meters per second. So rainfall excess is equal to 8 minus 0.25 for 6 hours, this is 6.5 centimeters. So the peak discharge of unit hydrograph is equal to 455 by 6.5, that is 70 cubic meters per second. So option A is correct. Question is, according to Kennedy, the critical velocity V0 in meters in a channel as the mean velocity which keeps the channel free from silting as covering. Its value is given by, so V0 by Kennedy is given as by 0.55 d power 0.64. This is in SI units. The D is in SI units. Whereas 0.84 d power 0.64 in FPS units, where D is depth of flow. So here, which units we have to take, whether it is FPS units or SI units. Generally, we used to use the SI units in general. So the answer should be 0.55 md power 0.64. Option B is correct.
Let the limit extends to a logarithm of x minus a by logarithm of e power x minus e power a. It is in the form of infinity by infinity, so we can use L'Hospital rule. That is differentiating numerator and denominator separately. Differentiation of log x minus a is 1 by x minus a. Differentiation of log e power x minus e power a is 1 by e power x minus e power a into differentiation of e power x minus e power a, which is e power x, which can be written as limit extends to a e power x minus e power a by e power x into x minus a. Now again it is in the form of infinity by infinity, so we'll use L'Hospital rule again. So if we use L'Hospital rule, it will be limit extends to a e power x by e power x into x minus a plus e power x. We have to use UV rule in the denominator, and let us substitute x as a now. It will be e power a by this term will be 0 plus e power a, that is 1. Hence the answer is B. It is given that x plus 1 by x as 2 cos theta, and we have to find the value of x power n plus 1 by x power n. If x plus 1 by x is 2 cos theta, then x will be cos theta plus I sin theta, and 1 by x will be its conjugate, which is cos theta minus I sin theta. Now let us calculate x power n. X power n is nothing but cos theta plus I sin theta whole power n. By De Moivre's formula, we can write this as cos of n theta plus I times of sin of n theta. Similarly, 1 by x power n will be cos of n theta minus I times of sin of n theta. Now if we add x power n plus 1 by x power n, it will be 2 times of cos n theta, which is nothing but option E. We have to evaluate the integral 0 to 3 root x cube dx by Simpson's rule. Here the lower limit, which is a, given as 0, and the upper limit is given as 3, and the number of intervals is 3. So h is nothing but b minus a by n, which will be 3 minus 0 by 3, which is 1. Now let us find the values of x0, x1, x2, x3. Similarly, y0, y1, y2 and y3. Let us start from 0. If x0 is 0, y0 is 0. Now x1 is nothing but x0 plus h, which will be 1. So even y1 will be 1. Now similarly, x2 is nothing but x1 plus h, that is 1. So totally 2. And y2 is root 8. Similarly, y3 is 3, which will be root 27. Now let us use Simpson rule. H by 3 into first term plus last term, which is y0 plus yn, plus 2 times of odd terms, that is y1, plus 4 times of even, which is y2. Now let us substitute the values. H is 1 by 3, y0 is 0, plus yn, which is y3 here. Y3 is root 27, plus 2 times of y1, which is 1, plus 4 times of y2, which is root 8. If we simplify this, answer will be 6.169, which is not mentioned in the options.
Question is the angle which inclined surface makes with the horizontal when a soil mass placed on the ground and that attains its own shape is called angle of repose. So when you place a sand of certain amount of mass m, if it is a soil mass of 8 m, if you place it on the horizontal ground, when you place it, because of its internal connection, it will attain its own shape. So this angle with the horizontal is called angle of repose. Option A is correct. Question is the moment of inertia of a right angled triangular section of base B and height h about centroidal axis parallel to the base is bh cube by 36. Option C is correct. It is a direct question. We know that the two parallel railway lines connected by a reverse curve, each section having the same radius, if the center line is 8 meters apart and maximum distance between the tangent points is 32 meters. Find out the maximum allowable radius that can be used. The options were given as A 45 meters, B 60 meters, C 9 meters and D 32 meters. So for a reverse curve, we know that L square is equal to 2 zeta divided by P1 plus P2, or L square is equal to 4 R zeta. So R is equal to L square by 4 zeta. So L is given as 32 meters, distance between the tangent point is 32 meters, and zeta is equal to 8 meters, central line apart is 8 meters is given. So by substituting these values, 32 into 32 divided by 4 into 8, that is 32 meters. So option D is correct.